All right, let's get started, everyone. Thank you all for coming. We are delighted to be talking about workflows in nTop platform today. Let's go ahead and get started. Just a quick overview of what we'll cover. My name is John Graham. I manage our stellar team of application engineers. I'm going to give you a little overview, just a couple minutes on nTopology and kind of set the stage for Chris, who's one of our phenomenal application engineers or senior application engineer. He's the one that's going to go through a spectacular demonstration and walk you through what we're talking about in terms of workflows and how they benefit you and go into more deep detail and flush that out. And then again, we'll go into a question and answer at the end, and we'll wrap it up in about 30 minutes or so. First, just a quick background, and I'm going to keep these short. I'm going to fly through them because I really want you guys to see what Chris has. He's got some exciting things in store. So we'll go through this quickly. What is nTopology all about? What is our mission? Well, from the get-go, our mission hasn't changed. It's still the same, enabling engineers to design and ship these high-performing parts in the least amount of time possible. Again, it hasn't changed. It remains the same. What is driving this is a shift in today's technology. There's a shift in today's technology and particularly today's manufacturing capabilities. And now this paradigm shift, this evolution of sorts, it's really from the move from traditional techniques, traditional manufacturing techniques to advanced manufacturing, where additive manufacturing is one of the leading capabilities driving that. So as a result, it's forcing the current manufacturing processes and methods to shift as well. Now, for some people, for some users and some in the industry, that's very disruptive. However, in topology, we see this move to advanced manufacturing as a true driver to spur on more and more innovation. And so we are thrilled about it and we're very excited. And that's what nTop platform is doing for our customers, spurring on innovation. Now, let's take a step back. Why are these problems happening? Why are there issues with the design process? And why is there a gap between manufacturing and design processes? Now, if you looking at the main problems and what's stifling innovation, most engineers, many of them, a significant number, are spending a lot of time on low value work, maybe the cleanup of 3D files, moving knowledge to a CAD system from a whiteboard or a napkin or just someone's head, translation issues from a CAD tool to a simulation tool, then back to a CAD tool, then maybe additional cleanup, going to a 3D printer or a CNC machine, a lot of non-value added work. And so what you end up seeing is this fragmented stack of engineering tools that were all somewhat designed in silos, and they didn't really take each other's requirements into consideration. Now, if you think of it, CAD tools that were developed 30 or 40 years ago were really designed when drawings ruled. They were the primary means of documentation. And that's what modeling was all about, documenting your final product. CAD is a wonderful tool for that, and it still is. But you all didn't come here today to learn how you can better document an idea. That's not what we're talking about. It's about workflows that spur on innovation. CAD generally struggles with engineering work where innovating and innovative ideas is the main goal. The architecture was built with something completely different in mind, and you can't innovate fast when it comes to capitalizing on advanced manufacturing with what I'll call the tools of yesterday. If you want to take advantage of new technologies like advanced manufacturing, your tool set has to keep pace. You have to be more innovative to stay competitive. And by adopting tools that leverage things like automation and modern day compute power, in modern day representations of data. That's what nTopology is all about and what our architecture is. It's got something very different in mind as compared to what's been done before. Our data structure and our open platform, now that's something we're calling a computational modeling platform or even an algorithm-based platform. It's what's solving today's challenging engineering problems. So what are some of the benefits of having this different architecture in our software? Well, the data model is higher performing and robust, and it doesn't fail. Now, by the way, we've done several webinars over the past couple of months, and we've written a lot of blog posts on this topic. So please go peruse these on our website as you'd like and educate yourself a bit more because these are really exciting topics. And second, because of the way that we handle data through fields or what we're calling a field of data, this has this unifying effect around design, analysis or simulation and manufacturing, bringing those together. As those parties can feed data into our system, driving material and shape considerations to achieve functional requirements. That's what they're able to do, like people couldn't do before, right? And finally, this gets into the subject of today's topic, workflows. Our data structure and open platform enable the creation and use of these what I'll call replicable workflows. So things like automation are possible. Let's talk about this in more detail and spend the remainder of our time fleshing out this concept of workflows. So first of all, what do we mean by workflows? Because that can be a pretty broad statement and a broad word that doesn't mean much to some people. In the context of nTop platform, I would call them these configurable engineering processes that do several things. And this is not an exhaustive list, but these are several that I can come up with, several of the benefits of what these configurable workflows or processes do. And again, Chris is going to flesh these out in more detail and show you tangible examples. But some of the benefits: knowledge capture. Well, best practices and knowledge for sharing just about anything design related can be captured in nTop platform and through nTop algorithms. They can then be packaged up and consumed by anyone else. So very efficient way to do that. Automation, I mentioned that a second ago. Many of our current customers are using nTop platform to shorten, if not eliminate, some of these low value tasks like model cleanup, struggling with adding rounds or editing them on a model, shelling complex geometry for the purpose of lightweighting, to name a few. Enabling control. So if you want to create a black box process, meaning you have a very detailed workflow, you want to lock that up so no one can see it, you can do that in nTop platform. If you want to expose only, for example, 5 parameters of the 50 that you use to define a process, you can do that too. If you want complete transparency in the definition of your process, you can do that too. And anybody can go in and tweak it and call it the workflow their own. So you have the utmost control over how something is defined and then used down the road. Data integration is another. I mentioned this a moment ago. Because of the way that we use fields, design, simulation, and manufacturing data can then be unified. And so when data can predictably and reliably be handled, this not only aids in automation, but it's integrating what were traditionally considered disjoint data sources and a cause of an area of a lot of problems. And then finally, efficiency. So having repeatable, reliable workflows. Repeatable, reliable workflows through nTop's open platform architecture is really what this is all about. Now, just one or two more things to say before I turn things over to Chris, and that's mentioning one more thing about this open architecture of workflows. That's really what's making nTop platform very unique. When we architected this software from the beginning, we thoughtfully built this concept and capability into platform. Here's an example. Think of it this way. Authoring a workflow is much like creating a computer program, defining some inputs and getting some outputs. The thing is, you don't need to have intimate knowledge of the coding structure to get benefit from that, right? For example, I woke up this morning, I turned my PC on. I've probably used at least a dozen different programs since the time I turned my computer on until the time of this webinar. I have no idea how the majority of those were architected and what their coding structure is, and I don't need to know, but I can get tremendous value and use from them. Now, in the same way, workflows constructed in nTop workflows, they can be built and deployed by the best engineer or someone that has specialized knowledge by something. And others in the organization are certainly going to benefit from that. So I think it's a good analogy to understand one of the benefits of workflows and how those can be pushed out into an organization. I'm done talking. I really want you guys to see from Chris now his perspective, and he's going to walk you through a couple of examples and hopefully make this stick a little bit more. Chris, go ahead and take it away.
Thanks, John. As he's mentioned, today's session is particularly about workflows and how they can really provide value in sharing knowledge and increasing automation. Now, we all know what a workflow is at a definitional level, but what does it mean in the nTop platform software? How do they play themselves out, and how do they help you? At nTopology, a workflow is the accumulation of nested functions that outputs a geometry. Now, this workflow can range from something simple and basic, such as applying conformal ribs on a surface, but it can also easily run lightweighting operations through topology optimization. In shorter terms, a workflow for us is how you get from point A to point B, from an input model to an overall better design. And this is all scoped and tailored to the need of the user. Now, a quick example of what putting a workflow together looks like in nTop platform. We're going to create a volume lattice block, which is a function that essentially generates a lattice structure inside of a volume. And then we're going to nest it inside of a thickened lattice block. Now what we have here is a very short workflow that fills a volume with a specific lattice structure specified through these parameters. All I have to do now is drop in a piece of geometry, such as this cube. And we can see that the workflow that we've created finishes the job for us. Now, one of the biggest values that an nTop platform workflow brings to the table is its tailored reusability. In the case of this latticing workflow that I've just created, it was assembled in such a way that the input is simply a volume. If I were to attempt this on any other geometry, such as this brake pedal, for example, I'd be able to take the internal volume, drop it into the input field of the workflow, trim and tweak the lattice parameters just a bit, and output the same functional lattice geometry in an entirely different volume, but with minimal engineering downtime. What this means at a design engineering level is the ability to mitigate redundant work and capture the true design intent of what you're trying to accomplish. The value of the reusability of workflows like this becomes even more paramount when you can start working with much more complex outputs that can be seamlessly shared across your team. On the topic of more complex workflows, one of the ways this can be accomplished is with an iterative workflow. What this means for us is to natively reuse an existing workflow, nest its output back into it as an input. This may sound a little bit intimidating, but the example I'm about to show you should help clear things up. Here we have a much more expansive workflow that is enabled by the configurability of nTop platform. How we typically generate a random or stochastic lattice is that we take an input volume, a pore size, and a beam thickness. Now, this is great if you're diving into a design knowing what your output should be. However, if your idea of an optimal design is simply a reduction in density by replacing your solid material with a randomized lattice, you may not necessarily know what your final design will look like. You may simply know that your objective criteria is a weight reduction of 25 or 50%. So how did we leverage platform to accomplish a task like this? We were able to loop the lattice generation and measure the volume each time it ran. And depending on how off base the result is, it'll recalculate your new input values and get closer to the target. These lattice cubes that you see here were run through the algorithm 10 times to get these weight reduction results, with targets spanning from 10 to 75%. But if we wanted to run it on different geometry, such as these filtration disks, all we had to do was swap in the disks as an input volume, and the results can be seen here. The level of reusability was dictated by me when making these workflow iterations. I wanted the workflow to accept any volume regardless of shape. So that was designed into the process when I was putting it together. If I wanted to run these iterations in an even more expansive DOE, nTop platform offers the ability to access its unique capabilities through an extensible and headless API. With the design platform that nTopology provides, objective-driven workflows such as this and topology optimization become significantly more valuable as a reusable asset. A design engineer becomes much more empowered and effective once nTop platform provides reliable workflows that enable intelligent and high-performing parts. Now, there may be a question that is lingering on your minds, and that is, nTop platform can make some pretty cool stuff, but does it play well with my existing software packages? In short, the answer is yes. One of the biggest problems that nTop platform was initially conceptualized to address was the lack of unification between all the tools that an engineer needs to interact with on a project-to-project basis. Our answer to this was to ensure our workflows were comprehensive and full stream, allowing interoperability from CAD design to simulation down to manufacturing outputs. Now, this topology optimization workflow here is quite comprehensive. The initial imported step file is up here, and not only can we accept step and parasolids, but we can also take native SolidWorks or CATIA files and bring them into our modeling environment. From there, we convert to a volumetric mesh, perform an optimization, pan through the threshold to assess what looks best, and then perform a quick and thorough smoothing operation. Finally, we can rejoin it with the critical connection geometry to finalize your optimized part. With this, we now need to get the part off the screen and physically into your hands. Our manufacturing output can be your traditional surface mesh, such as an STL or an OBJ, both of which are recognized universal formats in the additive manufacturing ecosystem. But what we can also output is contour slices. These can be ported directly to your machine's processing software, so you can bypass those heavy STLs. Now, the key to reusing this entire comprehensive workflow, from design down to manufacturing, is the initial CAD import. If we were to go back and leverage the reusability of this full stream workflow, all changes to the initial imported CAD file will come downstream through platform and generate a new set of output contour slices. And that's exactly what we see here as we go through it. As you can see, the change in hole position and passive region resulted in a significant change in the resultant topology, but the workflow itself that was applied was exactly the same. If for any reason the designer needs to make modifications to this workflow, nTop platform enables an open and accessible environment to apply those changes as needed. With this level of interoperability, platform stands to unify the many existing software solutions an engineer typically needs to navigate. Now, we've taken a peek into some of these workflows and we can see how in-depth they can become. With a platform that enables significant parameterization over complex geometry, the question becomes, how can a user control that workflow and ensure that the captured knowledge is being distributed as intended? You could describe the nTop workflow as a robust series of nested functions or blocks that offers the engineer a significant amount of design control. However, the nTop platform software actually enables the user to package and compress this entire workflow without losing any feature fidelity. Now, these configurable workflows are portable and controllable so that they only expose the parameters that the design engineer intends to expose. By hiding the rest of these parameters, the design engineer can greatly reduce the risk by ensuring that the wrong variables are not modified or mistakenly tweaked in any way. By simply importing this packaged and configurable workflow, we can see that the entire previous workflow has been sealed into a single block with only a handful of exposed variables. Now, the only variables we see are the ones pertinent to this specific design exploration. In this case, our workflow essentially allows us to shell the geometry, sweep between some lattice options, and automatically generate fillets between all of the lattice beams and the adjacent shell. And from there, it can perform a section cut to show us what's inside. But to be clear, the compressed version of this workflow maintains just as much flexibility as the expanded version. Even more, these configurable workflows can be easily checked into your PLM system, just like any other file, so that your workflows can maintain the same degree of revision control as your design outputs. With a master version accessible to all team members, the design intent of a workflow can be reliably distributed amongst the team or across an entire organization. This level of control enables nTop platform to provide a solution to eliminate low value and repetitive work, mitigate risk through revision controllable workflows, and allow a reliable vehicle to share knowledge and design intent. Now, I know there are questions starting to come in, but before we start answering those, we're going to hold off just a bit more and let a few more roll in. In the meantime, I'm going to hand it over back to John to host the Q&A.
Hey, Chris, thank you. That was awesome. Always very impressive watching you run the software. If you can run to the next slide. Guys, just a couple of next steps to think about. If you like anything that you've seen, if you're intrigued, if you want to find out more information or how nTop is relevant for your applications, reach out to us, sales@ntopology.com. Of course, you can always go to our website, fill out a form, and we will get back to you just as quickly as we can. We are continuing to post blogs. We encourage you to go check that out, bookmark that page, get on our email list, and you'll be informed about new blogs coming out. And last but not least, future webinars. Go check out our site, ntopology.com. There is a resources page. You should be able to find the bar at the top. Click on that. You'll find out about more webinars coming up. I do believe we have one September 10th. Chris is going to be hosting that one. It'll be around a medical application. Even if you're not in the medical industry in that space, I encourage you to go. Very intriguing things that are being done. I'm excited for this one. So thank you all for coming. We appreciate it. And again, stay tuned for future webinars and we hope to see you on them. So thank you again, everybody, for coming. Have a great day.